So our speaker this afternoon is Rahul Sangoli from Apple, and he's going to talk about the power of the targets package for reproducible data science. Thank you so much.
Thanks for the introduction, Ben. I think I've unmuted myself. Is everyone able to hear me okay? All right.
Yes.
See a thumbs up. Excellent. So I'll get started. Before I do, again, the URL is here to get set up. I hope everyone's had a chance to get set up. All you have to do is clone the GitHub repo and then run renv restore to install the packages. Don't worry if you don't have it ready right away. I have a few slides to go through before we go to the code, and there'll be plenty of time for the packages to get installed. Um, so once we are in the code, I'll touch base with everyone again and make sure that folks are set up. All right. Here's a rough agenda. We'll stretch and compress depending on engagement and questions. And I have maybe 2 or 3 breaks planned. And there's quite a few exercises that I've planned. And let's see how we go through all of it. I like to keep things very interactive. I don't plan to talk at you through slides. So we'll work through code and do examples, right? So we'll start with some introduction. We'll talk about reproducibility. Um, then we'll go through some basics of targets pipelines and go through some functions. We'll go through how we deal with files, how do you read files and write files. Then we'll move to a few more advanced topics like parallel computing, dynamic branching, working with databases. And at the end, I have, a quote unquote more full pipeline example, which like brings everything together, right? And we'll keep some time for like wrap up and Q&A. Okay. Feel free to ask questions along the way. I'll try to keep an eye out on the meeting chat and answer questions. You don't have to code along. Absorb the fundamentals and the design patterns. All the code base is fully reproducible and it's going to be in GitHub, and you can always reach out to me after the workshop is over as well. Okay. So just a quick introduction on who I am. Um, I'm a data science manager at Apple today, where a lot of my work focuses on building scalable, end-to-end data science production solutions, predominantly in R. Um, I'm also in my sort of previous career, a mechanical engineer who's worked on designing and testing engines from small engines that go in pickup trucks to 4,000 horsepower engines that go in mining trucks. And I did a lot of data science on engines as well, and then I moved to Apple. I work in areas predominantly in like the time series kind of domain, time series analysis, forecasting, anomaly detection. I have a real passion for the reproducible aspect of data science, and that's where a lot of the inspiration for this workshop comes from. More recently, I've been getting into the MLOps side of things as well. I'm a prolific R package developer and recently trying to get into Python as well. But all my work is proprietary, so all the packages are internal to Apple, and so you won't see much on my GitHub public profile. But I'm R Sangole on GitHub. Feel free to reach out to me and connect even after the workshop is over. Okay, so let me address why I'm so passionate about reproducibility, right? At the risk of being a bit alarmist, we are sort of in a crisis today. All right. A 2016 Nature survey revealed that over 70% of scientists couldn't replicate others' experiments, often due to missing code or data. A study in 2025 showed scientists were only successful replicating 19% of the results of 56 studies in the biomedical field. A 2019 paper found that just 24% of 800,000 Jupyter notebooks on GitHub could be rerun. and only 4% of those reproduce the same results, right? A 2024 study very recently on code reproducibility in economics attempted to reproduce 67 economics papers and found that only half were reproducible, even with the author assistance and mandatory code sharing policies at the journals, right? So it's quite a challenge, and my personal experience as well, working in the industry now for 19 odd years, this is a challenge, right? When we open old code bases, and 1 year old is code, you know, do I trust that everything's going to run exactly the same and I'm going to get the results that I expect, right? So this is why we as data scientists, we must prioritize open, reproducible practices to build trust in our work. So how do we define end-to-end reproducibility, right? Very simply, given a set of inputs, we expect stable, identical outputs, irrespective of who runs it, where it's run, when in time we've run it, right? Once the authors publish something, I expect the exact same thing to happen each and every time. Now, to ensure reproducibility, there's a couple of things that we have to work on, right? Number one, the data. This one's quite trivial in that sense, right? We have databases, we have blob storage, you could have data archives where you have the input data that's archived and stable, right? Second is the runtime environment, right? What operating system are we running in? Which libraries and packages are installed? What are the versions of those, right? All of this can be solved using technologies like Docker, which helps lock everything down. So to make sure that the runtime environment remains stable over time and remains stable between users. Now, today I'm not going to delve into Docker, but it's another area that I'm passionate about and that my team and I have plenty of experience and expertise in. If you want to learn more, there's plenty of resources that I can share on working in stable Docker containers. Okay. The third bit is the code itself, right? Now, very trivially, version control, very common, right? Just keeping stuff in GitHub or GitLab, important for reproducibility, right? However, do it right. Make sure that we have a proper control on branches, we have release tagging, do we have documentation in place, etc. Right? Most folks are doing a decent job on that. The last bit of the puzzle is the execution bit, and that's what we're going to focus on today, right? Is our code in a state that's always end to end executable? Does it always give us the exact same results on each run? Is it trustable and transparent? Are we able to verify that everything within the code has run correctly without error? Every downstream dependency of some R object has fully updated. Do we have that transparency? Can we tell visually that our pipelines have run? Can we communicate to the end users the complexity in the code, the interlinking between the various R objects? If some input data has changed or a user defined function that feeds into an object has changed, are we able to tell if downstream components have updated? Right? What if the input data itself has changed? Are we able to discern the impact of these changes on our pipeline? That's what we're going to focus on today. And that's what this package called targets gives us with a lot more. Okay. So let's dive in. So targets as a package, what is it? It's written by this amazing author, Will Landau. He works for Eli Lilly. He explains it as so. Targets is a make-like pipeline tool that coordinates pieces of computationally demanding analysis. So imagine that you have an analysis that has many components. You're able to break down those components into smaller boxes, connect them properly, and the tool keeps track of all these connections. The package also skips costly runtime for tasks that are up to date. So what the tool does is for every little component in your pipeline, it'll keep track of whether that component has already run before. So it does caching, it'll keep track of what is the input data, what are the functions that feed into it, has anything changed. And so if you rerun the pipeline again and nothing has changed, you save a lot of time because it's like, yep, everything's already up to date and you don't have to rerun anything. It also orchestrates computation, it handles parallel computing for you, which is quite amazing, and we'll look at that. And if the current output matches the code and it matches the data, then the whole pipeline is up to date. The results are more trustworthy, and the targets pipeline gives you a very transparent way to query your own code to ensure that that is true. Now, just as FYI, Targets was released in 2021, which is a successor to an old package called Drake, which is also authored by Will Lenda. Yep. So I'm hoping by the end of it, it'll convince you that, at some point of our career, when we are building these production code bases, we end up with something that looks like this, right? We have scripts and scripts and scripts within a repository that all have to be run in some particular sequence to get the right results. Hopefully, we'll go from here to something that looks like this, right? A succinct, readable, trustable pipeline, right? That inspires confidence in your code base. All right. That's my pitch for targets. This is what we'll get into when we go to the workshop. We have some fundamentals to look at the basics and functions. How do we deal with files? And then we'll also look at some parallel computing, dynamic branching, working with databases, and end with a full example. That sound good? Do I have anything on the chart that I need to look at? I had a poll running, so let me see what folks have answered. Let's say 88% of the folks are new to targets, which is perfect. Because that's what I've programmed the workshop to be. It's going to be starting from ground up. Okay.
One of the questions, really quick, Raul, was with renv restore received an error. The project does not contain a lock file if you called snapshot yet.
Called snapshot yet. Oh, interesting. Okay, so let me open up our studio. So if we clone this and we run rn restore, oh, the snapshot. Let me see. Oh, Millen also sees the same error. Can folks put in the chat, is everyone getting the same error? No error here. That's interesting. On Mac, no error. The folks getting an error, is that, are you guys on a particular operating system? Yeah, so okay, let me say that if you're in our studio, make sure you open the project, and before you run rn restore, that you at least your active working directory is the working directory where which is the project working directory, which has the rn.log file. I suspect if I do something like this, if I go one up and I do rn restore, ooh, that's interesting. It still doesn't detect it. I was guessing that that's probably, oh, because that's probably what it is, because I have this project open. If I close this project, That's probably what it is. There you go. Is my screen still coming across? Yes. Okay. So I think if you open up the project, and by the way, I'm using RStudio because that's what most folks use. If you use something like VS Code, not a lot changes. Open the project, run rm restore, and I think that should work. Okay. So if you look at this repository now, everything that we're going to do is within this code folder, right? So there are a whole bunch of folders in there, and we're going to go top to bottom through the course of the workshop. So let's go into basics, 01 basics, and what basics is going to introduce us to is just the fundamentals of the targets project. Okay. So, typically we have something like this. So I have an example script here, which is very reminiscent of, sort of analysis that we do, right? This is what we expect. By the way, the reason everywhere I'm going to set working directory is because I have to simulate that, each of these directories within code is our project directory, and each is independent from the other. So going to set working directory, we are in there. This is a typical script. We load some packages. I'm using this data set from this NHANES package. Um, as an example throughout. It's a decent sized data set of 10,000 rows. We might do something very typical, like take the data set and subset it, right? So selecting a few columns. We might have something like a cleanup. So here I'm cleaning the names. Um, so if you use janitor clean names, it's a useful tool that cleans up names. So instead of having survey year, like capital case, it converts it into camel case, gets rid of special characters. I'm dropping NAs as well, right? So now we have 6,000 rows on this. Perhaps we calculate some summaries. So here's some means across some columns. Perhaps we have a plot, right, of something. Maybe we want to create a linear model. So here I'm regressing a couple of columns over uh, what is this, BP, diastolic average, I suppose. So here's a linear model and a summary, right? Nothing special about the code, just something that we typically do in data science, right? We take some data, we clean it up, and then we analyze it. The idea that I wanted to show here is how you would convert this from a script-based approach to a targets pipeline. Okay. And so if you open up the underscore targets.r, then it shows you the exact same script, but set up as a targets pipeline. Okay. At the top of the script is just library calls, absolutely exactly the same. I'm going to clean up just to make it a little more readable. Okay. Now, this part I'm going to slow down and really talk about. Look at my screen if you're not. The idea behind a targets pipeline is each variable that is in your script today is converted into a quote unquote target. So let's do a before and after. This was before, right? A very typical kind of, I'm going to shorten this, right? Where we take a data frame and select and assign it to a variable. The way we do it in targets, in targets parlance, you set up something called tar target. The first argument is the name of the variable, is what we assign it to. And the second argument is the command itself. Right? So we're saying, hey, I want to create this target called tibble NHANES subset, and the command to create it is this, right? Take a data frame and select a few columns. So that's how you convert from a script-based approach to a target-based approach. Now you're probably asking why all of this, and it's going to make sense shortly. Okay, so bear with me. I'm just trying to show you what the mechanics are of converting the script into a targets pipeline. So what I've done here is I've taken each of these variables, tibble clean, tibble means, the plot, etc., and I've created a list of targets. So here's the first one where I select all the columns. Here is the second one where I'm saying I want to have something called tibble clean. What is the definition of tibble clean? Take the subset, clean the names, drop any, right? Then I have a target. It's called tibble means. What's the definition? Take tibble clean and do some summarization, and so on and so forth. Okay. So once this is done, here's the advantage of doing so. Let's have a look at what targets is going to give us. One is you can now analyze what this pipeline looks like. So if I run this command called tar-viz network, it's going to analyze the contents of underscore targets.r, and it's going to generate a DAG for you, right? Now this is the visual representation of what the code is doing internally, right? We started with this tibble NHNA subset. We went to tibble clean. Tibble clean is now feeding three objects: the means, the plot, and the linear model. And the linear model is feeding mod LM summary, right? Now, right away, you can see the power of doing this, right? We've gone from something that looked like a script that even though I explained it to you, you would not be able to quickly understand or discern which objects are feeding which other objects in the script. And this is such a small script. This is just 56 lines. But moving it to targets, right away, it's so apparent what the script looks like, right? Now, what can you do with it? You can run something like tar make to run this pipeline. So let me run that. And what's happened here is it's loaded underscore targets, and it started dispatching and running each of this. So it starts the first one, runs it, completes it, so on and so forth, ends the pipeline. Okay. Now I'm going to show you something. I'm going to visualize the network again. Remember how this network showed that everything is outdated because it hadn't run yet. Now we've run it. Now if I visualize the same network again, it'll say that, hey, everything is up to date because I've run the entire pipeline. If I check the status of the targets, there's something called tar outdated to have a look at any outdated targets. Nope, nothing's outdated. Everything's up to date. Excellent. Now, how do I read things from this? In a script-based format, when you run the script, each of these variables is being created in memory, right? And so in the environment, in a script-based format, if I run this first command, I have tibble subset as an object in memory, and I can simply run it, right? If I call it and hit enter, I see it. That's because it's in memory. You notice in the targets approach, when I ran tar make, everything's run, but nothing's in memory. That's because targets isn't running all of these objects and loading them in memory. It's running these objects and caching these objects on disk. And I'll show you where it is a bit down the line, right? So now the question is, how do you query the contents of your own script? So there's something called tar read, in which I can read anything. So say we wanted to read the contents of tibble clean, I would run tar read tibble clean, right? And now I can see the contents of the object. Similarly, tar read, if I wanted to see the plot, tar read plot scatter, we'll read it, and now we have our plot, right? And so on and so forth. Now you notice that it's reading it and passing it back to this dot last value, right? It's not loading it into memory. So if I want to load it into a variable, I could do something like x is star readable clean, and it'll create x. There's also a shortcut called tar load, in which case it'll create an object with the same name as the name of the object, right? So that's another way to retrieve objects and get it into memory, right? Now I can query metadata about my pipeline using something called tar meta. So if I run this, let me expand a little bit, clean this up and run tar meta. You'll notice that at the back end, what targets is doing is for each of my targets, it's keeping track of things. So here's the target. The data that goes into it has a hash key. The command itself has a hash key. It keeps track of when I ran it, what is the size of the target. It's saving everything as a .rds format. It's saving it locally, etc., etc. And it even keeps track of how long it took to run that target, if that makes sense. Okay. There are lots of commands like tar destroy that can go and clean everything up as well. Does that make sense so far? I'm going to see if there's any questions. I'll pause here because this is really sort of the meat and potatoes and the core functionality of moving from a script-based approach to a targets pipeline.
There's one question that chat just added.
Is it possible to append instead of defining the whole list at once? Like my list is append tar target. Um, Yeah, you can define it however you like. Basically, when you run something like tar make, what targets is expecting is at the end of the underscore targets.r, it's expecting a list of targets. Okay, and how you come up with that list is completely up to you, right? If I define this entire list somewhere else as a function, and I just invoke that function here like so, where the output of this function is a list of targets, works completely fine. Okay. Yes, it should be a list with no name. Okay. How are we doing on time? We are half an hour in. Okay, great. I have no exercises on this. This was to introduce, in this case, so what you'll have to do in the append case is if you're trying to iteratively build something, you can assign it like my list and then just return my list at the very end. Honestly, I haven't tried assigning the list to a variable name, but I can try that in the end. Okay, I'm going to go to the next one. So that's the basics. Let's go to 02 functions. I'm going to clean up my environment. And I'm going to open up underscore targets.r run.r and the readme. Okay. So at the end of this section, there is a bit of an exercise. So you'll get a chance to play around with targets yourself. The only difference between the last code that I had and this code is a little bit of cleanup. In the previous code, all the guts of each target, each object was within the pipeline, making the pipeline quite big and cumbersome. In reality, we wouldn't define things like that. We would rather use some functions. So this code is just refactoring the previous code and extracting some of the guts within functions. So the difference between that and this is, let's have a look at it. So now what I've done is I've written a few functions for the columns, for the plotly plot, for the linear model at the very top, right? So a little bit of refactoring, and the rest of the code remains quite similar, right? We have our first target, which is just selecting the columns, but the columns are now defined in the function, so it's neat and tidy. Then I clean up the data set, I summarize, I create a plot, but now I'm using a function instead, right? And the function is in there, so on and so forth. Now, what are the advantages of doing so? One, it keeps the targets pipeline a lot cleaner, right? Easier to read. And there's some other strategies downstream we're going to say to even simplify this further and make it easy to read. Second, it does something really, really pretty. And let's look at that now. So I'm going to run on our running library targets, and let's visualize the network now. And now you see something different, slightly different. Okay. We now see some triangles along with our circles. Triangles are functions. Circles are objects. That's the parlance here. So you see that to create this subset, there's a dependency on a function called fn calls. This object feeds into tibble clean, which feeds three objects. The plot itself depends on two objects. One is tibble clean, but it's also the function that feeds into the object, so on and so forth. So now, very quickly, we have a lot more clarity on how we are defining our pipeline and what functions are feeding into each object. So it's not only the data that's feeding into the object, but it's the function as well. Running this is very similar to what we saw before, where everything runs. We can visualize things again. Everything's hunky-dory. Now, as things grow, if you want to say, hey, I want to visualize this, but I just want to look at my targets, I want to hide the functions because it's getting a little busy. You could do something like that as well. You could say targets only equals true, and now you visualize the targets, right? Again, if you see nothing's out of date, right? And tar progress is saying everything is complete, right? So now we can trust the results of things like table clean, table means, the plot, the model, so on and so forth. Again, remember, all the tar reads, nothing's coming into the environment. It's all just being printed to the console. If you want to load something in the environment, you could do something like tar load. Remember, tar meta shows you all the metadata. And now if you look at this a little closely, you will see that not only do we have objects being tracked, but now we have a few more functions that are being tracked as well. And each of these functions has a unique hash key. So if the function changes, targets knows about it, and it will rerun all the objects that only depend on that function, right? And it won't rerun the whole pipeline. Okay, so I think we are 35 minutes in, and this is a perfect time for an exercise. So I'm going to have a look at questions, but if you want to turn over and play around with this, I encourage you to open up run.r. Remember, in the 0 to functions, run.r, run things from top to bottom, and then I have an exercise here for you. To add a few targets. There's some stretch goals, play around with it, and let's regroup in 10 minutes. It's 12:05, 12:06. Let's come back at 12:15. I guess it's 12:15 my time. I'm in California, but in 10 minutes. Okay, I'll give everyone another minute, unless everyone's ready to go and we can keep going. I don't know if there's like a thumbs up capability here or something. Um, but if everyone's ready to go, we can. Okay. I'll wait a minute and then we can get going. I'll show you what the solutions are, and then we're going to dive into the underscore targets folder. So, all right. Let's get into it. Um, how hard or easy was that? I'm trying to calibrate myself on these examples as well. Based on what we've spoken of, was that okay to do? let's look at the exercise and the answers. So one was to add a target called table counts, which counts the number of rows uh, in table clean, say by these two variables. Then adding a target called plot bar to create the output, and then visualizing things. So what we'd do is at the very end, we would add these targets in here. And remember, because it's a list, not to forget putting the comma. Right? So here's table counts, which is a target, and the code for it is to create take table clean and maybe create a summarization, put a comma after that, um, and another target called plot bar, which is going to take table counts and create a plot for it. And there's a little function in there, and I can put the function at the very top over here. That's taking a table and creating a plotly object. If I do this and save it, and now we can visualize the new network using TarWiz network, and I hit enter. You'll see that because I'd run the previous network before, everything that's in dark green has already executed and is cached. And everything that's in this light green is new, right? You can confirm that with tar outdated, where it'll analyze it and say, hey, look, you have these two objects that you haven't run before that are new to the pipeline. And we could tar make. Now, by the way, I've always run tar make without any arguments, which is telling targets to run everything. But you could also give it an argument and say, hey, I just want to run table counts, right? And if I just make that, it's only going to make that one object and dispatch. So now if I visualize, you'll notice that table counts is dark green, it's complete. And there's one remaining. If I do tar make on the whole thing, right, it's all done. And now I can do tar, read, plot bar. Ooh, that's interesting. Did I get an error? Tarvis. So here's our table count summary. Okay. Oh, that's interesting. But yeah, obviously the plot has failed because there's nothing called BMI. So my plot function was wrong, and so this plot has failed. However, it shows that the object ran successfully. How did it not catch an error? That's interesting. Okay, I'm going to look at this again, but let me change this. Let's say this is N and add bars. Okay, this is perfect because I'm going to debug this with y'all and see. Okay, so some of the stretch goals were like, what happens if you add some white spaces or comments in a function? Try to change the function and force it to be invalidated. So, I mean, as you guess, adding any white space or commentary in a function doesn't affect the target. It doesn't invalidate the target. So targets gets rid of white spaces and comments and things like that. It only invalidates a target if there's a material change, which I did on tar on the function. So now if I do tar viz network, you'll see that uh, this is now changed. And so downstream, this is now changed. So if I tar make, it should make those two, and hopefully we have our plot. Why it didn't fail the first time? I'm going to look at that in the break, but I won't spend time on it now. Does that make sense so far? I went through the chat and answered a bunch of questions. Are there any other open questions at the moment? And feel free to unmute yourself and ask as well. if you want to. Some of the relevant questions that I feel I'm going to voice out is do you use targets in your development pipeline by first going a script-based approach and then converting it to targets, or directly writing targets? And to be honest, the answer is a bit of both. I have enough muscle memory where now I just, for the most part, go into targets unless I have something very quick and dirty to do, and then I'll write it as a script. Targets does offer a lot of caching, as you can see, and scaling that even for some small POCs is very useful. So I tend to use it. Another question I had was, and this is really important, I should have made a note in here, is do you run tar destroy at the end of your sort of run.r or sort of run script? And the answer is absolutely no, because it completely defeats the purpose of targets. I only put that in there, A, for myself, because when I was creating the workshop, it ended up creating everything. And before I want to show you, I want nothing in there. So you can see it running. So that's one. But tar destroy essentially goes in and destroys everything in the underscore targets folder, which we will look at in a little bit. Uh, any other questions in there? Um, okay, so I think we are 50 minutes in, and how are we doing on the agenda? It's perfect. So I'm right on time. I had slated a 10-minute break. Do you guys want to do that now? Maybe grab a cup of coffee, stretch your legs, and come back in 10 minutes? Yeah. All right. See you all in 10 minutes. Ben, should we get started? All right. Welcome back, folks. Hope you had a good break. So we are now going to move into the third section, which deals with files. So on your end, if you want to move to code/03 files, make that your working directory, and you can clean your environment. um, do so, and then come back to my screen. So the way the rest of the workshop is all structured is for each section, I have exercises. So it'll be maybe 5 or 10 minutes of me showing you something, and then 5 or 10 minutes of you trying things out, and we can regroup and discuss. So what we're going to learn in this section is how we can use targets to manage files, input files, as well as output files. How do you import data? How do you export data? How you keep track of things? We'll also explore the underscore targets directory and see what's in it. So where does that metadata come from? How is targets keeping track of all of these objects? And then I'm also introducing two new topics, tar source and tar option set. Okay. So direct your attention to my screen. I'll walk you through everything, and then we will break for an exercise. So I'm in 03 files, and I'm going to open up the underscore targets. Now, immediately, one of the things you'll see is it looks a lot cleaner, a little cleaner than before. And that's because instead of having all the functions defined in this underscore targets.r, I've moved them to a different file as we would normally do, right? Because it can get kind of hairy. So all the functions for cleaning and columns and models and etc. can be moved to a separate file. And in targets, there's something called tar source, which just sources when it's running the targets pipeline, is going to source this function or this file, and then all the functions within that file will be available. Just helps things keep things a little clean. The second thing you'll notice is the star option set. And I just want to introduce this very briefly. Uh, it's a very powerful function, and it allows you to set all sorts of options for a targets pipeline. The only ones that I want you to look at right now is this format equals RDS, which is the default setting. And you'll see why I'm talking about it a little later. And packages. And packages is a vector of packages that the underlying targets pipeline depends on. So instead of calling them here as library, uh, you can put them in here as a vector of packages that the targets pipeline depends on. And there's a little bit of nuance as to why I'm doing it, and you'll see that a little down the line. Okay. So now let's get into how we can specify input and output files for targets. It's fairly straightforward. There's only one new argument that you have to look at. Okay. So in this folder, for example, I have another folder called data, which has a CSV file in it. Okay, which is the same data set we've been using so far. And I want targets to be able to read and track that CSV file. And the way I would do it is very similar to what we did before, is by defining a path first. So here I'm defining a target, tar target. I'm calling the target something like local file, right? And what is the content of that target is just the path. Okay, data slash the file name. Okay, the key difference here is there's a third argument that you want to set, which is format equals file. And this is what tells target that, hey, this is not simply a string, right? It's not a character vector. It's something that's pointing to a file. And I want you to go and I want you to treat that location as a file and keep track of it. Okay. If we look at what this network looks like, oh, I'm still in the previous one. Hang on. Let me change over. to 03 files. Wait, I'm able to show you errors as well. This is very interesting. What the joys of live coding. Report.markdown. Oh, I see. Report.markdown is missing. Okay, we'll get to it. Let's save. Okay. By the way, if you're gonna face this as well, report.markdown is missing on my end. Maybe I inadvertently deleted it, but we'll get to that. It's not a problem. So if I visualize the rest of the network, this is what it looks like, right? So we have this local underscore file target that I've defined that is now feeding into essentially a read CSV, right? And now it's the tibble, with the rest of the pipeline being exactly what we had before, right? We clean it, we model it, we have some coefficients, etc. Okay. So now if I tar make table and I change, it's going to run two objects. It's going to run the local file, and then it's going to run this object itself, and it's done a tar read, right? And the object is ready, right? I could tar make the whole thing and it'll run the rest of it as we normally do. Okay, so that's how you read in an object. Very similarly, at the very end, I have this object which is the linear model coefficients, which is just a tibble. And say I wanted to export and save that somewhere. In this case, I want to save it to data/model coefficients. Okay. The way I've done that is I've created another target. I'm calling it export. You can call it whatever you want, right? I am saying, okay, here's the string that gives the location of the output. I'm writing it. And I'm just returning back to the target the string itself. So if I tar read this, it's really just a string. Again, the reason targets is now keeping a track of it is this format equals file. This is what's telling target that, hey, this is not just a string. It's a string indicating the location of a file, and I want you to keep track of it. Here's why that's important. I'm going to tar with network again. And I'd say just targets equals true, just to make it a little cleaner, right? Everything's hunky-dory, and we've run it, right? If I go back to files and I do something to this object, right? This export, say I delete it, right? It's no longer there. Now, if I look at the network again, targets has noted that, hey, I had this thing, it was a file, I was keeping track of it at this location, and it's gone, right? And so now this target is outdated. Now, if I tar make again, it'll rerun that last little target, and now the file's available again, right? So that's how you deal with input and output files. Let's go to any questions on this so far before we go to the exercise. While we're doing the exercise, I'll figure out what happened to my report.qmd and I'll bring it back in the fold. But I have a couple of exercises here for you to get familiar with this aspect of targets. So if you go to README, so in your 03 files, you can open up readme.markdown, and there's an exercise here for 10 minutes. Have a look at it. Let's spend maybe 9 or 10 minutes on it, and then we'll come back and look at the results. All right, folks, I'm going to get started in just a few seconds here. Okay, we're 10 minutes in, so I hope that exercise wasn't too hard and you got to go through all of it. If not, no worries. We'll go through all the questions over here. So the idea was just to create a new target that calculates the mean BMI per gender, and then create a new target called export that writes it back into the output folder. Okay, and the solution is, as you'd expect, this is what it will look like. We have a new target called tibble means, which just takes tibble clean and summarizes it, calculates a mean BMI. And that tibble means is now fed into a new target called export. And we define the output file, save it, and then return that output file so that it's stored as a string. However, we tell targets that, hey, this is a file, so you need to keep track of it. If I put this in, run my tarviz network, you will see that I have two new targets that haven't run. Running tar make on them runs those two new targets. And as you'd expect, we now have a new file in the data folder. I put data in there, in the data folder, right? Called table means. Now, of course, like anything else, instead of data, I say, hey, I made a mistake. It actually has to be the output folder. I make that change. I tar make again. It's going to rerun and put it in the right place, right? If that makes sense. So remember to set format equal file for anything that's a file. Um, Now, I said try making a change in the input data itself. So we looked at a case where we deleted the file and then it keeps track of it. And that's sort of a trivial case, saying, hey, the entire file is missing. But however, what happens if you actually make a change to the data itself? So if I open up this file, which is fairly large, and say I delete a few random rows, right, of the data. This is now a changed data set. Okay. If I save that, go back here and run something like tar outdated, you'll see that now I suddenly have everything downstream that depends on that data is outdated. And this is again the power of targets, where it's keeping track of not only the code, but it's now also keeping track of the data, right? The local file has changed, and so everything downstream of it has changed. You notice that these functions haven't changed, so targets is like, those are fine, but everything downstream that affects this file has to now be rerun, right? Tar make it, runs the whole thing. We are happy with our pipeline. We can trust our results again, if that makes sense, right? The last question again was, what happens if you remove format equals file from the local file target, right? Then it's akin to just creating a new target with a string, right? This is file location, right? And if I had something like data slash empty cars.csv and I run this, which is fine, all it's done is it's created a string, right? Called empty cars.csv. However, it's not tracking anything because you've not told it what that it's actually a file. It's simply a string, if that makes sense, right? So far, so good. Was this exercise okay? Some thumbs up if you keep going. One thing that I didn't have, by the way, was the report.qmd file. Um, I think it inadvertently got deleted. So I've put that back in there. And the idea behind this was to show you that the output can be Quarto documents as well. So I'm using this function called tar render, right? Um, I'm calling the target, say, report. I'm giving it a path, which is a markdown Quarto document, right? And if you look at the Quarto document, it's um, it's a very simple document. It's going to output an HTML file with this title. But if you've used Quarto, you are able to even pass parameters to Quarto. So here I'm saying, hey, I'm going to have this set of parameters. One's called tibble_coef. All I'm doing in the Quarto document is I'm printing tibble_coef. Okay. Um, and I can pass tibble_coef through this params argument. Okay. In this case, I'm passing mod lm_coefs, which we defined here. If you do tar read, it's just a tibble. So I'm passing that tibble, calling it tibble_coef in params, which Quarto is going to try and find. And if I tar make this, it's going to go ahead and it will compile that Quarto QM report. It's created this HTML, which if you open it up, looks like this. So this is again really, really powerful because you can start doing a lot of literate programming where you can have your data pipelines and subsequent Quarto reports as part of the targets pipeline itself. And so again, if any of the data, model, code change, then all the documents change as well, right? And it's all part of this one pipeline. Yes, there should have been a report.qmd in the folder, and I had it, and I suspect at one of the Git pushes, I deleted it. So at the end of the workshop, I'll put it back in there and I'll do a Git push. One question is, why do you use curly brackets to define a file? Could you review the syntax again? Yes. And I'm sorry, I should have spent a little bit of time on that. It's nothing is nothing out of the ordinary. Uh, if you look at tar targets, and let me open up the definition. You notice, firstly, there's a whole bunch of arguments. We are only using the first two for the most part. Okay. The first is name, which is the name of the target. So new target, comma. And the second is the command. Now, I tend to not use the curly braces if the command is usually one liner, right? Empty cars, select mpgcy. Okay, perfectly fine. However, if you have a much a bigger command and multi-line commands, I'm putting those in curly braces, right? And so here I have some sort of an intermediate operation, right? Something like that, right? So on and so forth. So if you have multi-line operations, you could either specify them in curly braces, so it's all treated as one code block, or you could always abstract this out into some new function, right? Something like that, and then call it like so. That's all it is, if that makes sense. So theoretically, by the way, that also means that any of these places where I don't have the curly braces, you could define all of them with the little curly brace, just for consistency's sake. And that's completely acceptable. It just becomes, bigger code base. That's all. Okay. How are we doing on time? We are at 1:30. Okay. Let's move to the next one, which is super, super interesting. Oh, sorry. There's one more bit I wanted to go in here is the contents of the underscore targets directly. So let's do that right now. So what's happening when we run tar make or tar read? All that's happening is once the pipeline run, it stores everything in this underscore targets directory. In that directory, there's two components that you need to be aware of. One is this meta folder, and the second is the objects folder. The meta folder literally has a flat file, which is a table. And this is exactly the table that you see read when you run tar meta, right? It's reading this pipe separated file and rendering a table for you. That's the content of the meta. So this stores all the information about each object, the hash keys when you run it, etc., etc. The objects themselves are simply stored in this objects folder. So if you open this objects folder, you'll find a 1:1 relationship between the pipeline and the names of the objects here, right? And so this is where it's caching everything. So when we do something like tar read, say tibble clean, and we get a tibble, this is the exact same thing as doing read RDS underscore targets objects tibble clean, right? These are one and the same. And this is where it goes back to, remember where I had in this option set, add this tar option set format as RDS. This is talking about the cached object format. So everything in the targets objects folder is stored as an RDS. Now there's another format called QS, which uses the QS2 quick serialization package, which I highly recommend. In a future example, I have that because it reads and writes a lot faster, especially for large objects. Does that make sense? Does that answer the questions? I know I saw a whole bunch of questions asking where the objects are being stored, and this is exactly where it's being stored. Now, if typically you don't have to go into underscore targets and do anything manually. However, if you were to inadvertently delete one of these objects, which I don't recommend, and you run something like tar outdated, you'll notice that it's saying, hey, suddenly everything downstream of that is now outdated and needs to be rerun because targets can't find that object in the cache. Okay. All right. With that, let's move to the next section. I'm just going to clean everything up and go to 04 parallel. So the objective of um, this section is to understand how to now speed up our pipeline. So we've covered all the basics so far, right? How do you set up a targets pipeline? How do you get functions in? How do you read and write files? Now we're going to do a little more advanced. We're going to go into parallel computing. Okay. And so if we have a pipeline that's fairly large, how do you configure targets to start running things in parallel? We're going to look at another really powerful function called tar watch. And then we're going to see how all of that works together. Okay. So I'm going to open up some of these things here again. Functions is okay, underscore targets, and the run. So let's look at this new folder, and let's first visualize what it looks like. Okay. So in this folder, you notice that again, we have some clean data frame. Okay. And to make things a little spicy, I have a whole bunch of linear models in here, right? So each of this is taking this table and is just creating a linear model. So mod LM1 is regressing BMI over age, and then it takes that linear model and uses broom tidy to grab the coefficients and save it in mod LM coefficients 1, right? So here's a model, Here's the coefficients. Here's a model. Here's the coefficients. Okay. Now, to just slow things down because these linear models run quite instantaneously, what I'm doing is I'm adding like a sleep timer for 10 to sort of simulate as though this was a complex model. So imagine that this was some machine learning model that takes 10 seconds to run instead of instantaneously. Okay. If we were to run this serially, as you can imagine, targets is going to go and run everything one at a time, right? So if I do tar make on this, it's going to start dispatching each each model. So it started with LM1, that's going to take 10 seconds. Once it's done, it'll go to the next one, right? So on and so forth. There are 11 targets in all that are remaining, so it's going to go through one of them at a time. And you can see if I look at this compute graph, I'm not using all my cores. It's running 1 hour process in the back end, and that 1 hour process is evaluating each of these targets one at a time. But of course, there's a better way to do things, right? So let me just cancel this out. And we're going to now introduce another package called crew, which handles crew is a package that handles uh, creating and shutting down multiple workers. Okay. And the way you enable multiprocessing in targets is in tar option set, you enable this thing called controller. And you say, look, I'm going to have this crew controller and I'm going to give it 4 workers. And what this is going to do is it's going to tell targets that, hey, look, analyze the pipeline. And as much as possible, I want to parallelly run objects. And I'm going to allow you to have 4 active workers at a time. Okay. Now, if I run tar make on this, it's going to start dispatching multiple objects at a time. So I say, hey, look, out of all these objects, these are the number of objects I can possibly run in parallel, and I'm going to start doing so. Right? And now things run a lot quicker. So if I do something like tar destroy to get rid of everything and I rerun it, you see that it's now dispatched 4 linear models at the same time and they're all running. And as soon as those 4 are done, it's going to go to the next 4 objects because I have 4 active workers. And now suddenly your pipelines are running at scale. And so if you even have native code, that's not parallelized. So if you rely on some package where it's running single core, just moving to targets allows you to now run multiple workers at once with minimal overhead, right? It's just one argument that has to change. Yeah. So far, so good. I see some questions, and I'm just going to pause on them. I'll come back to them. But just on this, are we okay? All right. Now I'm going to show you something again. This part of targets is absolutely mind-blowing and I love it. So there's this function called tar watch, okay, which creates and launches a shiny dashboard, okay, at this URL locally. So I'm going to move to my browser and open that URL here. And so everything we've been doing so far was sort of like linear, right? We were doing tar with network, tar outdated, so on and so forth. What tar watch does is now running a process that's actively looking at your pipeline and reporting back here. Okay. So there's a summary where it says, okay, so far right now 11 are completed. Progress will tell you the names of all the objects that you have, what their status is, when they finished, how long they took, etc., etc. You notice that all of the coefficient ones ran in milliseconds, and the models, because I had the sleep timer, they took 10 seconds each. If I go to the graph will give you the Wiz network and it'll say, hey, look, everything's complete. Okay. There's some refresh settings, so I can have this run once, or I can have it auto refresh every X seconds. I can say, hey, look, I just want to see the targets only and don't show me the functions. On the next refresh, it'll just show you the targets. Great. You could add some labels, like say, I want to also print the size of each target. so that I can keep a track of that or at the runtime or what have you. Okay. Now here's the cool part. So I'm going to now tar destroy everything. And on the next refresh, it should be all blank because now there's nothing, right? And now if I tar make, before I do that, let me change something. Let me change the refresh to 1 second. So every second is going to go and is going to poll the pipeline. And now if I come back here, you'll see that, hey, look, it's dispatched 4, it's completed 1. And as it goes through, you can start keeping track of the entire pipeline in here. 6 are done, 1 is dispatched. If you go to the graph, you can again sort of visualize the progress from left to right as it's going through. Now, how cool is that? So this was introduced in one of the later versions of Target, and it's such a game changer, especially when you have really large pipelines and you're trying to keep track of everything, right? And so you can see the power of targets combined with the ability to run parallel workers. I think that was everything that I wanted to show you in this section. Okay, I can move to questions, and then there's also an exercise. How about I show you what the exercise is? So again, if you go to 04 parallel.r, run things in the run.r. There's the tar watch in there. I put a tar destroy just in case you want to clean everything and tar make again. Convince yourselves that parallelization is working. Play around with the number of workers. You can even comment out the controller and see how things are running. I said try adding a few more linear models, right? And see that it's working. Convince yourself that parallelization is working. Does adding more workers help? Do you know where you could monitor R processes and your CPU workload? And try to answer how many workers should you allocate to a pipeline, right? What are some constraining factors? Should we just default to as many cores as available? Think about that. I think this one, let's just take like 5 minutes, play through it, and then we'll come back and move to the next topic. Till then, I'm going to have a look at any open questions and start answering them in the chat. By the way, if folks are done early, just put a thumbs up in there or something so we can get started. We don't have to wait the whole 5 minutes either. Okay, let's get back into it. It's been 5 minutes, and any questions on this before we move on? Um, I had a few questions on chat that I answered. Boris, I see a new one from you. When a new data object is created, like a subset of data selected from DuckDB, is it also stored in the target's objects? Can we selectively empty this object if it's not more useful and occupies a lot of memory? Yes. So any object created within targets creates an RDS or QS object within this folder, right? Like you can see here. Now, if you had a whole bunch of objects that you later delete, so let's pretend, for example, this was our pipeline and we're iterating all this and we created these 5 objects and say later I'm saying, oh, these 4 models are, or these 3 models are kind of useless. I want to get rid of a few of them. I just want to keep a few models, right? If I tar make this, it's going to skip everything because, okay, great. I don't need 4 and 5. Now, these 4 and 5, all the metadata for it still resides in here. And to your point, if these objects are large, it's going to consume a lot of space. There's a command called tar prune, which then goes in and says, hey, look, I'm going to now compare the current status of the pipeline to all the objects that reside within the metadata. And I'm going to prune all the objects that are no longer relevant. So in this case, for example, it got rid of everything that was model 4 and model 5. And that's a way for you to like clean things up. Because as you iterate, you're going to end up with this massive objects folder with maybe very old objects that no longer are relevant. So tar prune is your friend. All right. Does that answer your question, Boris? All right. Before we move to the next topic, just the two questions in the exercise, right? How many workers should you allocate to a pipeline? What are some constraining factors? And should we just default to as many cores as possible? Um, and the answer is not necessarily, because oftentimes it's not the CPUs that become the constraining factor, it's memory. So especially if you have large analysis and you can imagine if you have models running in parallel and say there's something heavy, random forest models, XGBoost models, or something else, and say each model is going to take 400 megabytes of RAM to run along with 5 cores, right? Now that becomes your constraining factor because if you run too many of them in parallel, the CPU cores are not the constraining factor because if you just load your CPUs too much, everything gets throttled down and everything just runs slowly, no problem. However, if each model is going to consume 200 megabytes or two, 2 gigabytes or whatever of RAM, that just gets stacked on top of each other. And you're going to reach a capacity limit on your memory. And when memory limits are reached, things crash. And then things crash without warning. So you're going to have workers that crash without giving you any feedback as to why they've crashed. So if you ever try to scale up too much and things are very unstable, where sometimes it runs or sometimes it just crashes, and they have no idea why it crashed, and there's nothing printed to the log or there's no error being printed, check your memory. Maybe you just don't have enough memory to scale up like you want to. Okay. Are there any other questions? Okay. So with that, let's move to the next bit, which is just my favorite part, uh, and it's a huge unlock, and you'll see why. Let me quickly check. How am I doing on time, Ben? 155. Yeah. So we did files, we did parallel. Should we keep going? Does anybody want a break? Or let's get through this and then break? Since you guys are awfully quiet, I don't know, I'm just guessing. Okay, I'm gonna keep going. All right. So let's go to dynamic branching, which is in the 05 folder. And this is my favorite bit, and it's a very, very powerful bit, and you'll see why. It's a massive, massive unlock in productivity. Okay. So in this part, we're going to learn what is dynamic branching, how we use it. There's a few patterns of mapping that I'm going to show you. We're going to see how those kind of feed through the whole process. How do you track them and what all that means? Okay. So this bit is a little bit iterative. So if you focus on me for the next 5 minutes, then I'm going to change your uh, life with targets. I promise. Okay, so everything we've seen so far in terms of the branching is very simple, right? We had one object feed another object, feed another object, right? It's 1:1 relationship, right? And somebody in the chat was asking me about how do you like scale up when you have multiple objects. So in the previous example, for example, I had 5 models, but I'd specified each of those models manually, right? I said, hey, here's a name for model one, and I'm going to call a model one, and I'm going to give it this function, and then I'm going to call something called model 2, and I'm going to give it, and I was manually defining each target, which is fine when you can do so. But what if I have 20 models or 100 models, right? I mean, it's very, very cumbersome to start doing all of this manually. Not only that, what if going into the pipeline, I don't know how many models I have, right? What if the number of models or that definition is itself dynamic that I'm going to read from somewhere? And my desire is that I want targets to figure out, okay, I have this list of models that are coming from somewhere, and go read it And for each model, I want you to create a target and now track it separately and then whatever, do things downstream, right? That's where dynamic branching comes into, right? Like the name says, it's creating branches, but it's creating branches dynamically based on upstream components of data or code. Okay, so let's go through a few examples and see what that looks like in practice. Okay. Um, so let's change our working directory, go in here, and I am going to visualize something, which is I'm going to say targets only, and I'm going to add this label branches argument. And I'm going to show you what that looks like. And this is going to introduce yet another shape, right? So far we saw circles, which are objects, and we saw triangles, which are functions. And now we have squares. And what squares are dynamic branches. So the way I would read this is I have a table that's getting fed into this table list for education, whatever, right? And this is a box, so it's a dynamic branch. I do not know how many objects I have within. I could have one, I could have n, right? This n series of objects gets fed into a modeling layer, which itself is a dynamic branch. So I possibly have n models, which is feeding into n coefficients, so on and so forth. Okay. Uh, let's now peek into some of these and see what that looks like. So the objective here, and this is a very, it's sort of a very made up example, but that's fine. It is what it is. So I'm going to make the table tar make, and I'm going to read the table. And this is everything we've seen before is just a table, okay? Uh, and the example I'm forcing us to look at is I'm going to say, hey, look, I have this object. I'm going to create these linear models, but I want to create a separate linear model for each level of home ownership, okay? So if I do count home own, you see that the home ownership is either owning, renting, other, or any. And I'll say, hey, look, my business logic tells me that I want to create separate models for each of this data set. Okay. This is a perfect example to use for dynamic branching. Okay. So the first thing I want to do is just figure out how many levels I have for home ownership. And I'm doing that in this target. So I'm going to have a target called which is vector home ownership, and I'm just computing the levels. So if I tar make vec, I tar read vec, right? It's just a vector that says I have home ownership. Okay, so I have 3 levels in there. Now, what do we see? Those levels are feeding into this table list. So the next thing I want to do is I want to take my massive table, which is everything, and I want to split it into 3 tables, one for own, one for rent, and one for other. And the way I'm going to do that is, as you expect, I'm going to take table and I'm going to filter. Sorry, that's the wrong one. Where's my home ownership one? ED. This is the EDU one. Am I lost? That's table. Ah, okay. I did the home ownership for the cross one. Let's start with the education one. Vector education. So tar make education, tar read. So there's what, one, two, three, four, five. There's 5 levels of education. Same thing. So I want to create a model for each level of education. So I'm going to take my massive data frame. I'm going to filter education to be one of these education vectors. Now, right away, this is going to seem confusing. Rahul, what are you doing? Vector education is a length 5. You're not using percentage in percentage. You're saying equal equals, which means I expect vec education to be of length 1, right? I'm filtering to one thing. And this is where this new argument comes in called pattern. Okay. So I'm saying, hey, look, table list education, okay, is of pattern where I'm mapping this vector. And what it's doing internally is think of it like a for loop, right? This is like a map. And if you've used per map, right, and given it a vector of things, A and B, and then given it a function to do something, right? This is essentially what's happening within, right? It's taking each element of the vector and looping over it, passing it one at a time to wherever you've invoked it within the code, and then running that code. And that's why Tibble list education is now going to be a dynamic branch of length, what is it, 5. Okay. So if I now run tar make, okay, there's a few things here that I want us to look at. One is you notice that this is declared and it's saying, hey, look, this is 5 branches. Okay, so it's run 5 things. Now, if I go into the underscore targets, into the objects, what do you see? You see that we have tibble list edu. We have 5 of them with this unique hash key, each hash key for each component of that little dynamic branch. And I'm able to read each component by saying I want to tar read, comma, and you see the second argument, branches equals 1. So I want to read the first one. And so if I look at this, then this first one is 8th grade, right? The second one is 9th to 11th, so on and so forth. Third one, right? So that's what the dynamic branch is. So we've created a very simple dynamic branch like so, where we've taken the data frame, we've said, hey, we're going to split it into 5, and we now have a dynamic branch of 5. So far, so good. I know I covered quite a bit there, but this is kind of really important for things to work. Any questions on this so far? Okay, if not, I'm going to keep going. Okay, so now we have this dynamic branch, which is 5 of length 5. Okay, now we can build a model on top of it. So I'm going to say, hey, look, I'm going to build this linear model. Okay, my input data is this, what I'm calling tibble list edu. Okay, and here's the formula. This is everything we've seen so far. What's new in here is now this pattern, where I say, hey, look, I want you to now treat this input, which is a dynamic branch in itself, and I want you to map over it. So I have a list of 5 data frames. I want you to map over it, pass each of them one at a time to this linear model function, and create these models. So now if I run this, as you'd expect, this is 5 branches and each of them are running. Oh, the reason it's taking that long is I bet I have the sleep time. I'm going to get rid of that now. Okay. So this should run instantaneously. 5 branches run. Now if I tar read any of these, the first is the first linear model, the second is the second linear model, so on and so forth. And again, if you go into underscore targets in the objects, you'll see we have 5 linear models corresponding to the 5, right, with random hash keys assigned, right? And so on and so forth. So now same thing for the coefficients. Our make, oops, right? Now if I, by the way, if I tar read this without giving it a number, I'm just going to get a list, right? Now this is a list of 5. Here's the name, and then here's the underlying table under it. So far, so good. Thumbs up. Okay. So that's pattern equals map, right? So the map pattern is as you expect. You have a vector 1 through n, loop over it, and create targets dynamically. Now you could do something a little more complicated, right? There's something called cross mapping. By the way, there are a few more mappings, but this is the most common ones. The the map and the cross map. Okay. In the cross mapping, I'm going to use both of these vectors. So say I have something more complex, like say, hey, Rahul, I have a vector of 3 home ownership, and I have a vector of 5 education levels. And my business logic says that, look, I want to be able to create linear models for every combination of these two vectors, right? It's the same thing as doing expand.grid if you've used that, right? Uh, so, or using cross if you've used that, right? Saying, hey, for every level of own times all of this, run a linear model, so on and so forth. The way you do that is using this different input into the pattern. Oops, where did everything go? There you go. Here, cross mapping. So I'm saying, look, I'm going to create a new table list, which I'm calling home underscore edu because it depends on both, right? I'm going to take my data frame and I'm going to filter it where home ownership comes from this vector, education comes from this vector. And the way they'll be defined is I'm going to use this pattern and I'm going to use cross. And cross is what is telling targets to expand.grid, like cross multiply, run every combination and create this table list, right? So what's the length that we'd expect for this, right? It's going to be 15. So if I tar make this, we say we have 15 branches because it's the cross product of each of them. And I could read each of them from tar 1, 15, right? So again, this is really, really powerful, extremely useful when we have something like a main data frame, and perhaps you're running some machine learning project where you say, hey, look, I could run 2 or 3 types of pre-processes on the data. Maybe I can do a standardized scaling on one of them, maybe a min-max scaling on the other one with some other features. I could have some columns as factor variables, some as ordered variables, right? And so I have 2 or 3 types of data preparation, and I have maybe 5 types of models, and I want to run every combination of model and data pre-processing step, right? And cross is the way to do it, right? So because in one shot, it's going to run every combination and create all the models for you, okay? So we have this downstream is exactly what you expect. Now I have this table list. I'm going to create linear models and then create downstream targets. So far, so good. So now let me tar destroy this, and I'm going to show you what this looks like in the watch. So let me open up the watch here, right? So this is where branches will come into play, right? So here's a graph. I think it'll show that nothing's running. And just so we are able to see the progress, I'm going to go back and I'm going to put in this sleep timer again. So things run a little slowly. And now I will run tar make. By the way, this also builds on top of what we saw previously. So not only are we doing dynamic branching, but we also have a crew controller here. So I've put in more numbers of workers. So say we have 3 workers that are active at a time. Now if I tar make this, if we come back here, I'm going to say refresh every 1 second, you see that there are 3 dispatched. If I go to branches, you'll see that here's my models. I have 5 branches in total. 2 are dispatched, 1 is complete, so on and so forth. So it's tracking everything. I have 15 branches for this one. 1 is dispatched, 3 are complete, so on and so forth, right? You could look at this in the graph as well. And just from left to right, it'll keep updating as things are dispatched and then complete. So this is truly the unlock is parallel processing with dynamic branching. Okay, till this runs, I see a few questions. Per cross is deprecated. Can you also use tidyr expand grid? So that's interesting. I did not know per cross is deprecated. By the way, in here, so it's done. I believe that the cross that's been used, I wonder if it's, yeah. Uh, so I think the cross is coming from, I don't know if it's a native implementation or it's built on top of per, but it comes from targets. So the cross used here, I believe, isn't per cross, but it's targets cross. So I don't think you can use expanded grid as a substitute in a sense. I found that namespacing, map, and cross throws an error in targets. So Nicholas, were you trying to explicitly call out like per cross? Is
Yes.
that what you're thinking? Yeah?
Yes.
Yeah, I think that's probably what it is. Yeah, these map cross come from the star pattern in targets, and you notice there's some other ones as well, where you can slice things, or you can say, hey, look, I'm just going to take head or tail or sample. So there's kind of like various things you can do in there. Okay. So this is a good spot for us to pause. I have an exercise in here, but how about we take, should we do a 10-minute break and then do the exercise and come back to this?
You want
Ben,
to do a 5-minute break?
5-minute break? Let's do that. So take 5 minutes, come back, and then I'm going to leave this exercise up, play around with this. Let's do the exercise. Make sure you understand it because this is like the really the meat of things to help you scale up. So getting a hang of this is kind of important. Looks you're back from the break. I've just copy pasted the exercise here on screen. So let's take 10 minutes for the exercise. Try running things in the run.r and then try working through the exercise or just generally playing around with it and see if you can get it to work and if it's doing what you expect it to do. I think we'll come back after maybe 7 or 8 minutes and have a look at the solution together and then move on to the next bit.
So when did you want to resume? I'm sorry.
I think we should resume now. Like if folks are back from the break,
Oh, okay.
take your 5 or 8 minutes and run through the exercises. See if you can run the code, if it makes sense to you.
Okay.
How's everyone doing? Should we look at the solutions together and move to the next topic? Anyone needs more time? Just put it in the chat. Otherwise, we can keep going. All right. I don't see any thumbs up or not. So I think in the interest of time, let's look at the solution together again. So the idea was to create a dynamic branch to split based on age and decade. And so what we can do is, just like before, create a new vector, which is just the unique values of age and decade. And how many levels do we have in there? 2, 3, 4, 5, 6, 7, 8 levels. And then for each branch, calculate the mean and standard deviation of BMI. Okay, so that means we're going to take Tibble. We're going to filter for the age decade vector. And then we're going to summarize and calculate some mean and standard deviation, right? And again, remember the vector is of length n, 3, 4, 5, 6, 7. We want to filter each of them one at a time. So we add this third argument, pattern. And because this is a simple map, we're going to use map over the vector age decade. So I'm going to call that Tibble statistics, which gets run. There are 9 branches which gets run. And then we can read the outputs of each branch. So that's the first one, second one, sorry, 9. Oh, one's empty because of NA. I bet 8 has the last one in there. But somebody asked me this question in the chat on how NAs are handled. Boris, you asked. So if there are NAs within the vector itself, what I've noticed is in a map kind of function, those NAs don't flow through. So if you have NAs, I recommend pre-processing them and recode them to unknown or something like that. There is no like NA dot RM equals false in the map, at least as much as I know. So I always tend to pre-process them before I put them in. Okay. So one last point here, and I'm going to just touch on this, is add a downstream target that combines all of the summaries into a single tidy data frame. Now this gets a little interesting. So we could, for example, combine all of these because these are now 9 separate data frames, right? So you could read them and do something like bind rows, right? Where this is like a list of 9 data frames, and then you're going to get this one data frame. But something interesting also happens here that I want to show you. If I just read Tibble statistics directly, although it's a dynamic branch, you'll notice that I get a data frame back by default. Now, how is that? That means what targets did is internally it did a row bind. Okay, and targets tends to do that. So if you have a pattern that's a vector, so if instead of tibble statistics this was a vector, it would combine the vector by default. If it's a tibble, it will row bind by default if you just read the entire thing. If you obviously give it a branch number, it will give you each branch separately. However, it is possible to tar read the whole thing. Now, sometimes this is great because you know that, hey, look, my internally I have a list of tables. I want to tar read and just get the whole thing back. Great. Sometimes I don't want that. I want I want to force the user to make a decision. And a lot of times I don't want it to give this behavior. And you can change the behavior by this other argument. You must have noticed in some of these targets, I had this third or fourth argument called iteration. as list. And what this is telling targets is that, hey, look, I have this pattern that I'm mapping over, but when I request and I want to read this object back in, don't try to aggregate it in some fashion. Just give me a list and always give me a list. And I like that a lot better because now it's type stable. I know that I'm always going to get a list back. So if I add iteration as list over there, I'll have to tar make again because I made that change. Okay. So now again, it's 9 branches that ran. But now if I read this, you'll notice that it's a list of those 9 elements, and the name of the element is with that unique hash key that gets saved in the backend. I much prefer this for most of my workload because it's a lot more type stable, and I know that I can always start read this and do like bind rows down the line to get my table back, right? So I kind of recommend using this. Nothing wrong if you don't. And if you look at the documentation, I think there's a um, few more arguments you can give for iteration as well, right? So I think by default, for example, I think it's vector, where it essentially like puts everything together. List is what I like to use. There's also a group by, but I've not used that yet. Okay. So far, so good. Let's move to the next one if there are no questions. I'm going to close all of this. How are we doing on time? We're a bit behind. So what I'm going to do is for the database bit and the full example bit. I think we have 25 minutes left. I certainly don't want to keep you for that long. So I'm going to rush through this a little bit and at least give you a flavor for what all of it is. I don't think you're going to be missing out on anything. So I won't skip anything that's important. Don't worry. So I'm going to move to 06 database. Let me open up run. Let me open up targets and the README. Okay. So this section covers how do you integrate databases in your pipeline, right? Both reading and writing. So we're going to look at examples where we connect to a database, we query data within the database, and then we can have targets write results back to a database. Okay. And additionally, I'm going to show you one new concept called triggers or queues. Okay. So queues are rules that targets uses to decide whether a target is up to date or not. And I'm going to show you a new trigger, and there are many, many triggers you can use. I'm going to show you one new one. Okay. So let's move to the code. In this folder, you'll notice I have this workshop.db, which is a SQLite database that I created, and it's nothing fancy. If you open up this create database.r, you'll see how I created it. I'm using R SQLite. I did a db connect to create this file. I'm literally taking the data that we are using and just slicing it as the first 100 rows only, and I'm writing to it. Okay, so this database has one table called data, and that data has 100 rows of that data set. Okay, so that's what it is. Now in targets, how do I deal with databases? The first thing, I'm just adding a few new packages in this example. So we always use dplyr and janitor and all of that. I'm adding with R, DBI, and R SQLite. R SQLite only because that's what we're using. If you're using something like DuckDB or Snowflake or what have you, you can use that package in there. Let me scroll down to the target, and you'll notice that it's really, really straightforward. I don't know how familiar everyone is with R. Um, if not, I'll talk about it. For now, just ignore that bit. Okay. Getting data into targets for a database is exactly how you do it anywhere else, right? We have a connection object, which is something like DB connect, where I'm connecting to the SQLite database, right? In your real world example, this connection object could connect to a Snowflake database or a Postgres database. You could manage that connection object outside the targets pipeline, where you're sort of pre-connecting and creating a connection object and then giving it to the targets pipeline, because you might have to handle your credentials from somewhere, for example. right? So con is literally a connection object. DBI. Oops. Dplyr. Oh, that's perfect, right? So it's a connection object to this workshop.db, okay? And then you've seen this before. If you haven't, this is using the dbplyr kind of syntax where I'm connecting to this database and I want this table called data. If I run this, if you've not used dbplyr, what this is doing is it's creating a lazy connection to that table, right? So here's my table called data, unknown number of rows, 76 columns, and here's a preview of that data, right? And if I want that data completely into memory, I run something called collect. Again, this is none of this is part of targets. All of this is part of dbplyr or dplyr. So if you haven't used that, highly recommend looking at dbplyr and dbi packages to connect to databases. So now if I hit collect, it actually goes in, queries the data, and brings it into memory, right? So now I have a table with 100 rows and 76 columns as a whole data set, okay? So in targets, that's exactly what we're doing. We're saying, hey, look, here's a connection object. Go and grab stuff. The stuff that you've grabbed, I'm creating something called table from database. Now, what is this with database connection? This is nothing but an equivalent to doing something like this. So if we didn't have this, then we create a connection object, right? Like so. I collect something like so, and then it's doing on.exit dbi db disconnect connection, right? So all we're doing is saying, hey, look, go make the connection. When you finish running, make sure you disconnect. So it's a clean disconnect. And here's the code. But instead of writing all of this, the with our package is like a convenient wrapper on it. So it's like with DB connection. So it's like, here's a DB connection that I wanted to create called con, do stuff within it. And once you're done with everything in the squiggly brackets, go and disconnect that connection. So it's always a very clean connect disconnect, right? So highly advise using with R. So if I run this now, it's exactly what you'd expect. Connects, grabs data, disconnects, right? So far, so good, straightforward. Now, the one new thing I want to talk about is queues, right? That I mentioned. So how does targets know when it needs to rerun a target? Well, so far we've seen the very obvious kind of intuitive ones, right? If the upstream data going into the object has changed, it's going to invalidate it, right? If the code has changed, it's going to invalidate it, right? So in here, if I now do something like dplyr filter age greater than 10 or something, then it's going to invalidate it. Yep. However, what if I want to do something fancy? One of the fancier things that I would want to do is maybe I want to invalidate based on age. So that's where something like tar age from this tarchetypes package is useful. This tarchetypes package is a sister package to targets. You don't need it. However, it has a whole bunch of wrappers and convenience functions around targets. So it's super, super useful, very powerful, lots of cool stuff in there. Over there, it has something called tar age. And it has an argument for age where I can say, hey, look, I want you to invalidate this target after some amount of time, in which case I've put 1 minute. So I said, go run it. And it runs just fine. Oh, age run. There you go. I think it's small page. There you go. Right? And this exists. However, it's not out of date. But if I wait for 1 more minute, it's now going to invalidate this. Now, this becomes a very powerful paradigm if I know that, say, upstream data is going to come in at some frequency, and I want to invalidate my targets based on some kind of like cron job, right? And I don't have a good way of knowing whether my upstream data has changed or not. So tar age is useful. Just wanted to show you what it looks like. Make sense? In the exercise, I had something to write back to the database, and I'm not going to spend time in separating that exercise out. So let's just look at what that code looks like. So the idea was, hey, look, I want to filter age greater than 40, and I want to create a new table and write it back. Well, it's fairly as you'd expect. The reading is connect to the database, create a table connection, create your filter, aggregation, what have you, and collect. So now we have this new target called age greater than 40. And now take this table and write it back to the database, which we can use the db write table command. So again, with R is, hey, with this database connection, what connection? This one. Go connect, use that connection, create a new table called whatever, data gt age 40, write this and overwrite in it, right? And so if I run this now, it's going to go and write that table back to the database. Fairly straightforward. And this is also 90% of everything you need to know to read to and write from databases. Any questions so far? Nope. All right. The last stretch, and I promise you won't have to listen to my voice after this, is I put together sort of a more full-fledged example of what a pipeline might look like. Okay, so no exercises here. This is what, you can just see and look at some changes. So the other things that sort of incorporate into this example is a little more structure into how code is organized, because everything I've shown you so far is excellent for really small examples or toy examples. But once you start scaling out to production level pipelines, it becomes a little bit cumbersome. And so small tweaks on how we organize code will keep things structured. Okay, so if you look at that underscore targets.r, it's fairly similar to what you saw, except for two changes. One is now I have two new folders. One is called pipeline and the other is called R. In R, it's a bunch of functions, right? But it's just better organized. So there's some functions for data, some functions for modeling, some functions for plotting, some functions for post-processing. By the way, this toy example that I created is to use the diamonds dataset that's in the ggplot package, which is a whole bunch of metadata about diamonds and is trying to predict, I think, is it the clarity or something? Is trying to predict one of the classifications of the diamond, the cut, I think, right? Okay, so these are all the functions in there. Now, if you notice, my pipeline, my targets pipeline is no longer a massive list of targets. Okay, it's a list, but I just have a list of what I'm calling pipes. And these pipes I've defined in this pipelines folder. So in the pipelines folder, for example, my first one, pipe data, is just a list, right? But it's a list of all my targets that deal with the data bit. Then my model pipe is just a list, which is all the targets that deal with the test train split, preparing recipes and all. It's all using the tidy models framework. If you haven't seen that before, it's fine. It's just creating machine learning models. So think of these models as any modeling pipeline that you may have. And then I have a post-processing pipeline, which is a list of targets that do plotting, for example, and reporting, right? And this keeps my underscore targets definition very succinct. This is great because as you start creating, maybe 20 odd pipelines, you can't have just a laundry list of targets. It becomes, thousands of lines of code, impossible to debug. The other advantage here is it's very quick to comment and uncomment. So say I had to debug just the data bit, I could comment the rest of the pipelines, right? And start and just start with network and look at it. And now you can see that my pipeline is fairly small. It's like, okay, a few things. So you can sort of like start dissecting things. So this is a sort of a useful thing to do, right? If I uncomment all of this, then here's what that pipeline looks like, right? We start off with raw data, we clean it up, we do a data split into train and test, we prepare a recipe, we train the model using the recipe and the training data. We use the test data to predict on, and we have confidence matrices, importance, variable importance plots coming from the trained data, some metrics for the models. We have plots and we have a report, right? A very typical kind of machine learning pipeline. And you notice that some are circles because all of these are individual targets, and these are boxes because what I've done is I've defined the models, the machine learning models, as a dynamic target. So I could have n number of models which all feed through. Okay. So that's the organization. Pipelines reside in pipelines. The functions are in R. I'm sourcing them here, and then we run. And that's really a full kind of a pipeline. So making this, it'll take a bit of time because there's 23 targets to run. If I had tar watch running on this, you could see them running. It's going to end up with a bunch of plots. It's going to create the report. The report's going to have some variables, importance plots, and things of that nature. Right, model metrics, confusion matrices, importance plots. Save it as an HTML, and everything runs. Again, the beauty of this is once we have this done, we commit our code, push. Anybody pulling only has to do a tar make on their end, and everything should run end to end, just as it did on mine, right? So the report is done. Here's our HTML. Let's see if this works. View in web browser. It opened it in my screen over here. And so we have some, model performance report as to how the random forest did and what the confusion matrices are, etc., etc. Okay. All right. So that's really a whirlwind tour of targets. So just to recap, we learned what targets is, why reproducibility matters, how to build modularized target pipelines. We talked about files and quarter reports and databases, all the basics there. Looked at some parallel compute, looked at some dynamic branching, sort of a whole example together. I want to leave you with two sources. So these are both written by the author of targets. One's a user manual, which is my go-to if you're trying to learn this on your own. There are chapters that talk about all of this and go through a lot of detail. The documentation is excellent. Lots of detail in there as well. And there's a lot more that we haven't talked about. How do you handle packages? There's some advanced archetypes. There's even cloud storage. So you may want all of those target objects instead of having them stored locally to be stored in the cloud, right? You could have distributed remote compute. So instead of having workers run locally on your laptop or your machine, you may want to deploy workloads in the cloud and then get the results back. Targets does all of this for you. It's pretty amazing. I hope I convinced you enough to where you're going to try and adopt it and make our pipelines work a lot more reproducible than they would be if they were simple scripts. And I think that's all I have for the workshop.
Thank you so much, Rahul. That was terrific. I hope others will join me in thanking you for your presentation and the details and walkthrough. I know it's never easy doing live, and I think it's terrific. I think targets is going to be of tremendous value for a lot of the attendees, and I know for myself. So we really appreciate the time taken on this. I did want to allow others for questions, but I do have to leave, and I apologize, to get ready. There's a demo session that starts in about 5 minutes, and I have to prepare the speaker for that. So I'm going to leave, and I'll turn over to you, Raul, to finish up if there's maybe some last lingering questions or some kind of post notes that you wanted to add at the end. So thank you
Sure.
again.
Cheers. Thanks, Ben. If anybody on call has questions, I mean, unmute and talk to me, or we can go back through anything if you want to. Try to see if there's anything in the chat. I don't see any new questions.
And thanks a lot for the absolutely excellent lecture and so rich in examples and highlighting different functionalities of the package. It's really amazing. So compliments. I just, maybe you explained this, but I didn't catch the thing. Is it whether it's possible to invoke the targets pipeline from external script?
Yeah, I
I
should.
mean, to define a parameter, something like a question that I put in the chat is, can we set in Plumber an API endpoint that will run targets pipeline and take all the parameters for the targets pipeline ran from the API post query?
Yeah, I don't see why not. So what you want to do in that case is, say we have the API being serviced somewhere. Now, I don't know how it's set up, but I can imagine that you have an API call that's, say, ingesting some parameters, right?
Yes.
You have two parameters that the user is giving you through the API call. I'm assuming then we want to run some targets pipeline that has your business logic, models, etc., right? That are going to give you some output, and then the output has to be returned to the user. I haven't designed APIs myself, but as long as you have the input saved in a location that target knows where to look for, it's like any other script, right? If I'm assuming you have this setup today, and this business logic is in some script where it is a sequence of function calls, correct? All you're doing is replacing that by a targets pipeline. And then the script itself would be just to run tar make, right? So I mean, if you're doing this was like command, like if this was shell, for example, if this was a shell script, it could be something like, right? Right. And so what this would do is it would say, hey, look, I have this pipeline set up, and my underscore targets has my targets that know where to expect X and Y to be located. Perhaps your API is going to write X and Y to some temporary files, and it's always in that one place. Target's going to look at that, read it, do your business logic, and put the output again in a place where you're able to service that to the user, right? So you could set that whole thing up and run it simply with a tar make. That's the invoke, is the tar make.
Okay, thank you. So in any way, it's necessary to write the X and Y variables or any other parameters to the disk. I mean, to a file that will be taken by the pipeline and processed.
You could, do you want to pass it perhaps directly to the script instead of writing it? Is that the intent? Is like, hey, I have this in memory and I want to like pass it to a script.
Yeah, but exactly, sorry, but I didn't catch how it's possible to pass to the script external variables. I mean, if we define X and Y, not in the script,
Yeah.
in the targets R file, but somewhere else, and we don't want to write it as a separate file. Sorry, as a separate file to the disk. How
Yeah.
is possible to transfer these variables to the target script?
I think I've done this in the past. I believe our script, there's an ability to pass arguments which get fed into the script. I'll hunt for it. If you can connect with me offline, I'll hunt through my code and I'll give you an example for how it's done.
Okay, thank you so much.
All right. Any other questions before we stop? By the way, I'll make sure I'll update that missing QMD document and push it. And if you go to my GitHub repository, you should have, fork it or clone it. I'll keep it up to date and you should have everything in there. So the presentations here, the link on the right, and all the codes in there. And if things are not working or you want to communicate with me, just open an issue and we can talk after the workshop is over as well. All right. If there's nothing else, thank you so much for listening and joining in.